Now we are going to discuss the 2 by 2 tables for RCTs. You must have an idea about RCTs. What are they? Randomized controlled trials. And in RCTs, we have two groups in which we have treatment group and placebo group. And then we have an outcome present and outcome absent. So in order to make a table for RCT, what we would take here a treatment group, and here we would take what? Here we would take a placebo group, or you can say a control group. Here on x-axis, what we would take the outcome, because obviously what we are doing in RCT, what we do in RCT is that we manipulate one or more variables, see the outcome. Okay, so here the outcome is present, and here what we would have, the outcome absent. Okay, rest of the thing would remain same. Here we have treatment group, obviously one treatment group in which we have done some intervention, and then we have placebo group in which we did not did not use any new medication, or we did not give medication, and then we are seeing the outcome. This is basically the RCT. What we can see in the RCT is basically the same thing, almost the same thing. As we found out the odds ratio, here we can also find out the odds ratio by you know how?
Cross product.
By
Cross product.
cross product. And what it would be? It would be A
A
into
into B.
divided by B into C. Simple. Okay. Then what we do is that we also measure here the ARR, or you can say ABI.
Yes.
But here the formula of ABI or ARR is, previously we discussed that absolute risk in exposed minus absolute risk in non-exposed. Now we don't have any exposed or unexposed group. What do we have? We have an experimental group and a control group. Okay, this placebo is also known as, you can just write here, the control group, and in the treatment control group, and in front of treatment group you can also write an experimental group. Why? Because we are doing some sort of experiment, right? It is an experimental group. So what would be the formula here for ARR or ABI? What it would be? It would be the difference between experimental event rate and control event rate. Now, in order to find out the ARR, we should know that what is experimental event rate or ERR, and what is control event rate, CER. To find out what is EER, let's see the table. Experimental group, experimental event rate. In how many patients who were experimented, who were in the treatment group, the outcome or event occurred? It is A by A plus B, because we have A plus B people who were in the experimental group. Okay, and out of this only A showed the outcome. So experimental event rate would be simply A by A plus B. Similarly, how many controls, out of all the controls, how many showed the event? So it would be C by C plus D.
C plus D.
C plus D.
Okay, simple. This is the total number of control group. This is the total number of experimental group. And now we are seeing the outcome, number of outcome, that how many times out of these what represents the outcome. So this is basically EER. What is EER? Experimental event rate. That means out of A plus B, which is basically the experimental group, in how many patients does the event occur? A. And in how many control patients did the event occur? In C number patients. Okay, so EER is basically A by A plus B, and CER is C by C plus D. And now we have the values for EER and CER, we can easily find out the ARR, which is basically absolute risk reduction, or ABI, absolute benefit increase. It is basically nothing but a difference between experimental event rate and control event rate. And similarly, it's very easy that if I talk about the risk ratio, what it would be?
ER divided by CER.
EER divided by CER. Okay, simply. Is it clear?
Yes, it is.
Okay, great. Now, what we are doing, we can find out previously if we see that how many things we were able to calculate for cohort: odds ratio, risk difference, which is ARR ABI, and risk ratio RR, relative risk. This is a simple thing, or you can say relative risk. Now we have another thing which we can which we can find out in terms of RCT. What is it? What is it?
Relative,
Is RRR. What is RRR?
relative,
It is relative
relative
risk
risk
reduction. Okay, or you can call it, RBI, relative benefit increase. Okay,
Yes.
and what is the formula of RRR or RBI? The formula of RRR is basically ARR, which we have measured, divided by control event rate.
CER. Yes.
Okay, sometime it is also known as, sometime we can also write it as, it is also equal to 1 minus RR. And if you know the basic maths, then you can obviously calculate that what is ARR. What was ARR?
ER.
What was
EER
ARR?
minus CER.
ER minus CER divided by CER. So if we just
Yes.
calculate it can lead to it is equal to 1 minus RR. Okay,
Yes.
so it is basically, you should know all these formulas. And now if we can see that if RRR is equal to ARR divided by CER, then it means we have another formula of ARR, not just this formula, but we have another formula which is basically what? RRR.
RRR times CER.
Okay? This is very high yield and very important to remember. Okay, so this is another thing, this is a new thing which we can find out for RCT. Okay, now we have another thing which we can find out for RCT, and that is what? NNT. This is what? Number
Needed to
to
treat.
treat. Okay, simply the formula of NNT is
1 divided by
1
ARR.
divided by ARR or ABI. Okay, this is basically what? NNT. NNT is 1 by ARR. Is it clear? We have another thing,
Yes.
which is question expected event rate, but we will discuss it when we will solve the questions, because that is it is already very difficult to digest all of this thing. So I just want you to focus on the things which we have discussed today. Okay, so talking about NNT, the ideal NNT is basically 1. Okay, the ideal NNT is 1. We have another term which is also known as NNH. NNH is basically nothing, but it is the same thing, like it is same as NNT. The numbers needed to treat, it is basically the numbers needed to harm. If the event is -1, then NNT would become NNH. What is NNH? Number needed to harm. Okay, is it clear?
Yes.
Perfect. Okay, so now we are moving on with a very important thing, which is point of no difference, and you all should know this in order to solve the questions, and it will also help you in reading the articles, and that is very high yield. What does it mean by a point of no difference? The point of no difference by the point of no difference, it means that. What are the values of no difference for all of these things which we just discussed, like odds ratio, ARR, RR, RRR, and NNT? Okay, odds ratio. What is the least, what is the value at which we can say that if the study has this much OR, then this study is insignificant? Remember, guys, what is odds ratio? Odds ratio is a ratio. Okay, so the least possible value which we can get from a ratio is 1. Okay, so the point of no difference is of odds ratio is 1. The point of ARR or absolute risk reduction, the least possible
0.
value could be 0 because it is a subtraction. Remember that thing, it is a difference. So
Yes.
the least possible value we can get is 0. If anyone is unable to understand, they can just raise their hand or just ask me in the chat. Okay, the point of no difference, again I'm repeating, the point of no difference means what what is the least possible value that we can get from these formulas. The least possible value for odds ratio we can get is 1 because it is a ratio. For example, we have 10 in the numerator and 10 in the denominator, then the least possible value we can get is 1. We cannot can get 0 from a ratio. Okay, but if we talk about difference, for example absolute risk reduction, then here we can have the value, the least possible value is 0. Okay, now if we are talking about the relative risk, the relative risk is basically again what?
1.
It is a ratio. It is a ratio. So the least possible value would be 1. Again, relative risk reduction, what is it? It is a subtraction, it is a difference. So
0.
the value would be 0, and the value for NNT, the least possible value would be point of no difference,
Infinite.
infinity. Why I am telling you all of this, let me just explain. Okay, why it is important to know about the point of no difference. For example, you have seen, you have read the research articles, and there you have seen these things. Okay, like they have written odds ratio is equal to 2.4 with 95% confidence interval 1.7 to 3.4. Can you just tell anyone that this result which is written in front of you, it is significant or not? Yes, you can. And how? Let me tell you. See what they are measuring. They have the value in odds ratio, and what you already know. You know that the point of no difference is for OR is 1. Okay,
1.
so the value of OR should be greater than 1. Always the value should be greater than 1. Okay, and one second, let me just explain. Okay, okay, so the value of OR should be greater than 1, the point of no difference. Point of no difference means your results are not significant. As you can see here, the what is the value of OR? It is 2.4. Is it greater than 1?
Yes.
Yes, that means
Yes.
your study passed the first step. Then move on to 95% confidence interval. This is basically the range in between which your value would lie. Okay, now see the range. What is the first value of the range? Is it greater than 1?
Yes.
Yes. And what is the last value of the range? Is it greater than 1?
Yes.
Yes. That means your results are,
Significant.
why? Because they are crossing the point of no difference of that value which they have measured in the research article. Are you getting me? See here, 2.4. This value is greater than 1? Yes, it is. 1.7, the first value of confidence interval. Is it greater than 1? Yes. the last value of the range, is it greater than 1? Yes. That means your results are significant. This means that you should know all the values of all the point of no difference of all the values, so that and in that so that you can find out the significance of your study. Now another example, I'm telling you that why it is important to remember the point of no difference for all of these things, because in research studies you will come across with these measures, like they have measured either their research studies in terms of OR, ARR, RR, RRR, NNT, etc. Okay, moving on. Now, what is the measure here? This is the second result. What is it? ARR. Okay.
Yes.
What is the least possible? What is the value of point of no difference for ARR? Tell me.
0.
0. Is the first value greater than 0? Yes. 0.2.
Yes.
Okay.
Yes.
What is the first value of range? Is it greater than 0?
No.
And the last value is greater than 0? Yes. That means
Yes.
one of the values is less than 0, and that means the results are not significant. Okay. And see, this is why it is very, very important. It is very important to know about the details of point of no difference. Let me give you an online example. Okay. Let me just give you an example. Let's see. We are seeing a forest plot of research article, any article. I don't know which article would come up, and I will randomly select one. Okay. I have select this or this, in which we have all the values. Yes, we have select this. Okay. Now, see, in what measure do we have here? Odds
Odd
ratio.
ratio.
You should know that the point of no difference for odds ratio is 1.
1.
Okay, 1. And now you will see, this is basically what forest plot, in which we have discussed, they have included all the studies, the secondary, it is basically the secondary research in which we have collected all the published studies, and now we are, calculating their significance. Okay, combined. So as you can see that we are measuring odds ratio here. So this should be popped up in your mind that the values should be greater than 1. Okay. Now see,
Mm-hmm.
now see. Is the value greater than 1? Yes, it is.
Yes.
But this one is not. This one is.
Point.
Yes.
This one.
Okay. This one is not. So as you can see, this is insignificant. This is significant. This is insignificant. This is significant. This is significant. Okay.
Yes.
Okay. Similarly, if we see this one, okay, what is the value we have? What value do we have here? Relative risk.
Yes.
Okay. What is relative risk?
1.
It is 1. Okay. It is a ratio. So as you can see, this is this significant? No.
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 Okay. Is this significant? No.
No.
Is this significant?
No.
No.
Is this significant? No, no, no,
No.
no. So in this way, if you can
This.
just you can easily tell by just looking at the forest plot that, or by just looking at the the data, that is the study significant or not. For example, if you see here, it is risk ratio. Okay. Here we have two things. It is we have two sides of forest plot. This side favors the conventional, the old method, and this side favors the new method.
New method.
You
Yes.
As you can see, the measure is risk ratio. Okay. This ratio means the value would be 1. But as you can see that all the values have, they don't, they are not that, they are not that much significant. And that is why the collective result is more in favor of conventional treatment. So what I am trying to explain here is, you can easily tell about the significance of a study by just remembering the point of no difference. Is it clear?
Yes.
That was basically the the major reason for explaining this point of no difference. Okay. Okay. So thank you very much.